Hello guys, in this video I am going to explain you how you can solve this particular circuit using the nodal analysis. So to start with, first of all we need to select a node. So over here, since this is the point where the three branches are intersecting with each other, so let this be a node where we are going to apply the KCL. So to apply the KCL, like over here you can see there are three currents, I1, I2 and I3, and the direction of I1 is that the current I1 current is coming towards node A. I2 and I3, they are going away from node A. So to make it little bit simple, let me change the direction of current I1 and let me assume that the current is flowing away from A, and let this current be IA. So now if I relate I1 and IA, so it is simply I1 is equals to minus of IA. Now the reason I did this is that if I select the current direction is such that it is going away from node A, then what I can do, if I assume that let the voltage at A be V. So now what I can do, if this is my reference, so simply for branch having the resistance 7 ohm, simply the current IA, it will be V minus 12 volt upon 7. So we know that if we have two nodes or 2 points, let it be A and this is B, and if the voltage at A is VA and the voltage at B is V, and if it is R and the current is flowing in this direction I, then simply to calculate I, the formula is VA minus VB upon R. Now same thing, same formula we are applying for all the branches. So when I applied for the 7 ohm, so I got this, that IA, current is going from A towards this node or this node, right? So this value VA, voltage at this A node, it is V, and the voltage at this node, it is 12 volt, right? So V minus 12 and the resistance in between is 7. So I get this. Similarly for I2 current, for I2, this is I2, so it is VA and the voltage over here, it is 0 volt, so it will be VA or V, I have taken it as V, so V minus 0 upon 5, so it is simply V upon 5. And similarly the current at I3, it is V and the potential over here, it is 0 because it is connected to this, right? So V minus 0 upon 47 kilo ohm, which is V upon 47000 amperes, right? All are in amperes. So once I get the value of IA, I2 and I3, then applying KCL, simply I can apply KCL. What KCL say? KCL say that the sum of all the currents that are coming in or out of this node, the sum will be 0. So over here, all the currents IA, I3 and I2, they are going away from the node A. So simply applying KCL, I get IA plus I2 plus I3 equal to 0. Now substituting the value of this IA from here, I2 from here and I3 from here, what I will get? I will get V minus 12 upon 7 plus I2 is this, so V upon 5, plus I3 is this, so V upon 47,000 equal to 0. And now simply if I solve the value of V, so I will get, I am writing the value directly, you can solve this on your own. So once I get the value of V, now by substituting the value of V in this equation, I can get the value of IA. So IA, it will be 4.997 minus 12 upon 7, and I will get the answer as minus 1.00429. Similarly, if I substitute the value of V in this over here, so it is V upon 5. So the value of V, it is 4.997 upon 5. So I will get something as 0.9994 ampere. And similarly for I3, if I substitute the value of I3 over here, so it is V upon 47,000. So it is 4.997 upon 47,000. So I will get something as 0 this, right? So you can see I get all the three values. And now we also know that I1 is equals to minus IA, because in the question it is given I1, so I should calculate I1. So simply I1 is the negative of IA, so I1 is equals to minus of IA, so it means minus of this value, and so minus minus will cancel out and we get 1.00429 ampere, right? So we get the value of I1, I2 and I3. And now if you look at the values, you will find out that the value of I3, it is too less in comparison to I2 and I1. This is I1, right? So it means that almost all the current that is there in I1, it is directly transferred to I2, and very small current is transferred to I3. So now if I look at the circuit, so from the circuit you can see that the resistance over here, when the current is passing through the 7 ohm resistance, current when come to IA, then the current has two paths. One is to flow through this 47 kilo ohm and another is to flow through this 5 ohm. And since 5 ohm is very less in comparison to this 47 kilo ohm, so most of the current will try to follow the path that has less resistance. So almost all the current that is there in I1, almost all the current is passed through this branch of 5 ohm, and minimum current is flowing through I3. And so we get very less value of I3, and I2 and I1, they are almost same. So in this way we can verify our answer. So if you have any doubt, you can share your questions in the comment box, and do subscribe my channel, share this video with your friends and colleagues. Thank you.